Here I'm going to introduce the concept of slope, which is something that you definitely need to know for the test. And slope is just really a measurement of how slanty a line is. If you think of a ski slope, you have your black diamond, which, so for example, if this is the coordinate system, and this is the ski slope, something very steep would have a very high slope. Whereas if, for example, you're on the bunny hill, the slope is a little bit more gradual. So that's all slope is. It's just a way to identify how slanty a line is. Now the slope of a line is either going to be positive or negative. It's either going to be a positive number or it's going to be a negative number. And a quick way to know if it's going to be positive or negative is by thinking about it, is it going downhill or is it going uphill? So for example, again, I'm drawing these on a coordinate system. So like here's your X and here's your Y, because you're going to plot points and plot lines on the coordinate system. If you look at the line from left to right, so here's our line. If it's going downhill, so if you were a person, you're standing to the leftmost part of it, if you're going downhill, you're going to have a negative slope. So that the number is going to be a negative number. Similarly, if you have a line, and let's say you're standing on the leftmost part, and you're going to be going uphill, you're going to have a positive slope. So it's just going to be a regular, a regular positive number. So in the test, you might get a question where they're just going to show you a line and ask you, is this a positive slope, a negative slope, zero, undefined? So if it's going downhill, it's going to be negative. It's going uphill, it's going to be positive. So that's something, and you can think of, down and it kind of has a negative connotation to it. Up has a positive connotation to it. So that's one way that you can remember that. If you have your coordinate system and you have a line that's horizontal, so that means it's parallel to the x-coordinate, it's just going straight across, that's going to have a slope of 0. If you have a line that is going straight up and down, vertical, that's going to have a slope that's undefined. And I'm going to show you this mathematically. But this is important to remember. It's going to make your life easier. Negative slope, positive slope, 0 if it's perfectly horizontal, undefined if the line is perfectly vertical. So on your formula sheet, you have the formula for slope. So you don't even need to memorize this. And what it says on your formula sheet is m. M is the variable that we normally use for slope. So slope equals y2 minus y1 divided by x2 minus x1. You'll also hear this referred to as rise over run. Now why is that? If you remember on the coordinate system, if you don't know what a coordinate system is or how you plot points, you need to watch that video that I have on Facebook. But you're going to be given 2 points. So let's say we're given point 2, 5 and 4, 8. So here are 2 points, right? If we're going to plot this, again we have the x-coordinate and the y-coordinate. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to plot these 2 points. We'll plot the first point is 2, 5. So if this is 1, 2, 1, 2, 3, 4, 5, we're going to plot it right here. second point is 4. 1, 2, 3, 4, and up 8. So we count up 8, and it's up here. So these are the 2 points. We've just plotted them, and we're going to connect them and figure out what is the slope of the line that connects those 2 points. So right away, we know this is going to have a positive, the answer is going to be a positive number, right? Because it's going uphill. So we're going to use the formula. We're going to call this point 1 and this point 2. It doesn't matter which point you call 1, which point you call 2. It makes zero difference. But we'll call this one point 1, this one point 2. Remember, this is the x component because that's how many spaces we move along the x line. So we'll call this x. Since it's point 1, we're going to call it 1. This is the y component. It's how many spaces we move up and down on the y line. So that's the y component. Since we're calling this point 1, we're going to call that y1. Here's point 2. So this is x2 because it's point 2, y2 because it's the y component and it's point 2. So we have x1 is equal to 2, y1 is equal to 5, x2 is equal to 4, y2 is equal to 8. So you just label the numbers in your 2 points. And then we simply plug them in. So y2, well, we called y2 was 8. Minus y1, y1 was 5. Divided by x2, x2 is 4. Minus x1, x1 is 2. 8 minus 5 is 3. 4 minus 2 is 2. So our slope is 3/2. That's the answer. If you're asked, what's the slope of this line defined by these 2 points? The answer is 3/2. Now, why this is kind of referred to as rise over run, because look at what's happening. In the formula, we're subtracting the 2 y's from each other, right? The y components. So for starting here, we're first finding the difference between the rise. How far up are we going? Because we're taking the y component minus this y component. And then we're doing what's called the run part, where we're finding the difference between this way, between how far we're running across the x component, because we're subtracting this x component from that x component. So we're taking the difference in the rise, we're dividing by the difference in the run. And that's why it's called rise over run. But really, all you really need to do is when you're given 2 points, label them appropriately, put them in the formula, and you're going to get the right answer. So let's try another one. So here, let's say we have 3, 2 and 6, 1. So again, you're given 2 points. They want to know what's the slope of the line that connects these 2 points. So again, we're going to call this point 1 and this point 2. This is the x component, so we're going to call it x. It's point 1, so we're going to call it 1. This is the y component. Of any point, you have x and y, so it's always x, always y. This is point 1, so we're going to call it y1. Again, x component, so we're going to call it x. It's point 2, so we're going to call it x2. Y component is point 2, so we're going to call it y2. Let's look at this line. 2, 3, 4, 5, 6. 1, 2. So here we have point 1 is 1, 2, 3, up 2. And then we have point 2, 1, 2, 3, 4, 5, 6, and up 1. So we have a line that looks like this. So automatically we know our answer better be negative. We're just going to plug into the formula. Again, the formula is on the formula sheet. So all you need to remember is how to label the points, which is pretty easy because every point is an x component and y component. y2 is 1. y1 is 2. Divided by x2 is 6, minus x1 is 3. 1 minus 2 is negative 1. 6 minus 3 is 3. So the slope is negative 1/3, which is right, because remember, we know that it's going to be negative. So the slope is negative 1/3. Generally, they're going to leave the slope in fractional form. Now, we really don't need to draw this out, right? The graph is really doing nothing for us, except it's kind of giving us a clue as to whether this should be positive or negative. But all you need to do is label the points, plug them into the formula, and you get the answer. Remember we said that if it's a horizontal line, you're going to get 0. So let's say we have points like this. So we have point 1, we're going over 3, up 2. We're going over 2, up 2. So we have a perfectly horizontal line. Again, this is point 1. This is point 2. x1, y1, x2, y2. y2 minus y1 over x2 minus x1. And we're going to get 0 because 2 minus 2 is 0. 0 over anything in a fraction equals 0. So that's why anytime you have a horizontal line, you're going to get 0 because you're subtracting the two y components on top, which are equal. It doesn't matter which point we choose, the y is always going to be the same. It's always going to be 2. It doesn't matter where on this line. So you're always going to have a 2 minus 2. So you're always going to get 0 when you have a horizontal line. Now when we have a vertical line, remember we said that it was undefined. So let's say we have 3, 1 and 3, 4. One, 2, 3, 1, 2, 3, 4. So we draw the first line over 3, up 1. Second point over 3, up 4. So we connect the two, and the line is perfectly vertical. Again, we have point 1, so this never changes. You're going to do the same thing. x1, y1, x2, y2. Plug in here, so y2 is 4, y1 is 1, x2 is 3, x1 is 3. So here we have 3 on the top, but we have a 0 on the bottom, and that is undefined. You cannot divide by 0. You can't have a 0 in the denominator. That's why vertical lines are always undefined. And so you can see why, because you're always going to be subtracting. We're subtracting the x's. The x's are the same. It doesn't matter where you are on this line, x always equals 3. So it's always going to be 3 minus 3, putting a 0 in the denominator. So that's the basic idea behind slope. Just remember, you're most often going to get questions where they're going to give you 2 points. You just need to designate one of them as point 1, one of them as point 2, and then label it x1, y1, x2, y2. Look at the formula on the formula sheet, plug in the numbers, and get the answer.